Okay, we're going to take a look at gradient functions and how they relate to tangents and instantaneous rates of change and so on around a curve. So what we have here is Desmos has drawn us a tangent to a parabola, to the red parabola here. And what we should be able to notice is that as I draw tangents to various points on the curve, they're all positive on this side of all the tangents that I draw on this side of the parabola. All are going to have gradients that are positive because all the tangents are going up. They're going up, and so they are positive. So it doesn't matter what point I am on. I draw a tangent, I draw another tangent, I draw another tangent. All of these are all going to be going up, so they're all positive. They all have positive gradients. We don't know what they are, but at this point we know they're all positive. And as we keep moving these tangents through the parabola, we can see that as we get to the turning point here, we get a horizontal line. The tangent becomes a horizontal line, which we know that the gradient of a horizontal line is 0. Now we start moving to the right-hand side of the parabola, and we can see that as we move this green dot, creating tangents, all these tangents are going downhill now from left to right, and they all give us negative gradients. So these are all negative, 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 0, positive, 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 positive. So that's something that we need to make sure that we understand, okay? Now, how does this all relate to gradients and gradient functions and so on when we sketch those? Let's just put this thing on 3, negative 3. X is negative 3. Now, we want to know what the gradient is for this tangent. Now, we know we can go to the calculator and we get the gradient, or we can do it by hand, which is very cumbersome, but still, we can do it. If I just need a couple of points, and then I can do rise over run, and I can find the gradient of this tangent on the curve at x is negative 3. So that will tell me the instantaneous rate of change along that curve at x is negative 3. So I go 5, 10, 15, 20, 25, 30 over 1, 2, 3, 4, 5, 6. So I've got a gradient of 6. Now I've got no context for that, but basically what I have just discovered is that this tangent has a gradient of 6. What does that tell me? It tells me what the instantaneous rate of change is on x is negative 3 on this curve, and it's 6. Okay? Now, that's kind of cumbersome, and again, I can get that quite easily from my calculator if I put it in. And I could do that for over here at 2 if I wanted to, but let's just keep it on at 3 for the time being. Now, I'm going to put something else on Desmos. Desmos will allow me to figure out what the gradient is at that point by doing a number of functions. So this purple point that I put on here at x is negative 3 gives me this y value, 6. Well, guess what? We just found this out. This is the gradient of this tangent, 6. So this point represents at x is negative 3, the gradient is 6. So this purple point is telling me what the gradient is along this curve. All right, now let's keep going. Let's go to 0. Right, so here's this purple point is here because at x is 0, the gradient is 0. So there's the point that represents the gradient. And then if we go to 2, purple point is going to tell me at x is 2, the gradient of this tangent line that we've drawn here, this black tangent line, is a negative, and it's in fact negative 4. And if I went to 3, oh look, gradient is negative 6. It's negative. We know it's going to be negative, and there's symmetry here, so it makes sense that it's going to be a negative 6 because again it's going down. So you can see that these purple points, if you watch them, are making a straight line that has a particular orientation representing the gradients. And what we can do is I can just show you what that gradient, that orange line becomes the gradient function. Because at x is negative 3, the gradient is 6. So this is a point of negative 3 and 6. and 0 and 0, and 2 and -4, and 3 and -6. These all fall along this orange line, so this becomes the gradient function of this parabola based on the gradients of the tangents at various points along the curve.